Hi friends, welcome to Vegetable Calculus. In this video, we are trying to determine the length of this circle. This is still one-dimensional calculus because we are only trying to determine the length of this circle and my finger can go through this circle. If there is something in between, like the other onion rings, then that becomes a two-dimensional calculus. But for now, because it's only one circle, that's one-dimensional calculus. And also, for it to qualify as one-dimensional calculus, we need to deal with polar coordinates and not rectangular coordinates because they have both x and y coordinates here. So if we use polar coordinates, then only that becomes one-dimensional. And do you remember the cylindrical coordinates? If you take a cross-section of a cylinder, that's a circle. Spherical coordinates, similarly, if you take a cross-section of a sphere, that's a circle. So in one-dimensional calculus, cylindrical coordinates and spherical coordinates are not different. They are the same. And they are nothing but a circle. Okay, how do you find the length of this circle or the circumference of this circle? We need to know what r and theta are. At a constant radius, it's just circles, like r is equal to 1, 2, 3, they are all circles. At a constant theta, say theta is equal to pi over 6, it's a ray like this. Okay, why do we want to know constant radius and constant theta? Because if we freeze one of them, we can determine the limits of integration for the other. For this particular case, we only want the limits of integration for theta and not the radius. In one-dimensional calculus, we only deal with one integral, not two integrals. And the reason why we want to determine the limits of integration of only theta and not the radius is the radius is fixed for this circle. Whatever is this radius, let us say the radius is phi, and that's fixed. Okay, which is very good because now we already know the radius is frozen. Let us see how the theta is varying. So at a particular radius phi, how is theta varying? Theta is varying from 0 and so on. It's intersecting here, here till 2 pi. You can clearly see this, right? Theta is varying all the way across and it's tracing, it's intersecting here, and it's tracing this entire circle. So the limits of integration for theta are 0 to 2 pi. We know the length element is r d theta for polar coordinates. Now if you do the limits of integration, or if you evaluate this integral of d theta is theta. We know this rule, right? Integral of 1 dx is nothing but x. Same way, because r is not connected with theta, integral of r d theta is r theta. Limits of integration are 0 to 2 pi. And if you substitute the limits of integration, that is 2 pi minus 0, which is 2 pi r. Thank you for watching. In the next video, we'll deal with two-dimensional calculus and I'll use more interesting vegetables. Thank you. Bye.